right, example 3. We're going to have a few graphs here. We're just going to focus on graphing the horizontal stretch and compression. The reason for just focusing on that one transformation is because they tend to be kind of tricky to graph. So we're going to spend a few minutes looking at those. All right, so transformation that's happening. I have a 1/3 inside the parentheses. So when the number inside the parentheses is less than 1, if you look at your transformation chart here, when the number in the parentheses is less than 1, like this guy, that's a horizontal stretch, and you're going to stretch by the reciprocal of that number. So I have a horizontal stretch by the reciprocal of 1/3, which is 3. Okay, so for this problem, I'm going to graph the parent function first. You don't typically have to do that if you don't want to, but in order to demonstrate what's happening to the graph, I want to graph the parent function. Okay, so here's my parent function. And you know those, or you should know those points. Now, when we did vertical stretch, the vertical stretch affected the y values because y is going up and down vertically. Horizontal stretch affects the x values. So our x values will change this time, and the y values will stay the same. So when you think about the origin, that origin is going to stay the same because it's 0, 0. So you're going to be when you multiply by 3, the zeros don't change. Now, if I look at this next point here, 1, 1. If I'm transforming the point 1, 1, the y is going to stay at 1, but the x here is going to get multiplied by 3. So 3 times 1 is 1, or I'm sorry, 3 times 1 is 3, the y stays the same. So this point goes out to 3 up 1. And by symmetry, we'll have -3, 1. The next point on your graph is 2, 4. Again, the y stays the same. The x is multiplied by 3. So that's going to be the point 6, 4. And then symmetry gives me -6, 4. Do you see how this is going to work? So the last point I'm going to change is 3, 9. The y stays the same. The x gets multiplied by 3, which will be 9, 9. So 9, 9 up here. And that, when you connect those dots, gives you a wider graph, which is good because we wanted a horizontal stretch. And that would be the graph that was horizontally stretched by 3. Okay, let's try it again. And b, I have y equals 2x squared. Now this one, because the number inside the parentheses is greater than 1, that means, just like this problem here, I'm going to have a horizontal compression by the reciprocal of that value. So here I have a horizontal compression by the reciprocal of 2, which is 1/2. So this graph's going to get half as y, so it's going to get narrower. Again, for this problem, I'm going to graph the parent function so that we have a reference for where to go. You don't have to do this every time once you get the hang of it, but for now, I want to graph it so we can really understand what's happening. Okay, our horizontal compression, 0, 0 is going to stay the same. Again, I'm multiplying the x value, not the y value. So if I go up to the point 1, 1, the y stays the same. The x value gets multiplied by 1/2. So you're going to go to the point 1/2, 1. So it's going to be a little squeezed in there, but you can make it work. It'll be easier with your pencil. The next point you change is 2, 4. 2, 4, the y stays the same. The x gets multiplied by 1/2, which will be 1. So plot point 1, 4. And let's do 3, 9. The y stays the same. We'll take 1/2 times the x value, which is 1.5, or 3/2. So we'll go to 1.5 to 9, right up here. And if you look, you can squeeze that graph in, and it's really narrow, but that is your parabola, the purple one there. It's horizontally compressed by half. All right, C, 1/4 x squared. Oops, I think those are all typed wrong. They should have parentheses. Sorry, guys. Like this. That's okay. So we'll have 1/4 x squared. So all those x squared should be outside of the parentheses. Okay, 1/4 is less than 1, so it's a horizontal stretch. Or I can spell horizontal by the reciprocal of 1/4. So this time you're going to multiply every x by 4. Now, on this one, I'm going to try it without graphing the parent function. But you should know the ordered pairs for the parent function, at least the right side. So if you need to reference those, write them down or think about them. And those are going to be the points that we are adjusting. The 0, 0 is not going to change. 1, 1, you're changing the x, multiplying it by 4. So that's going to go to 4, 1. Stretch way out here. Negative 4, 1. 2, 4, when I multiply the x by 4, will be 8, 4. And it looks like that's all that's going to fit on my grid, because when I multiply 3 by 4, I would have the point 12, 9, which is going to be somewhere up here, just for your reference. Okay, so we can connect those dots and see that you have a horizontal stretch. All right, last problem for this example. Again, it's written kind of wrong. It should be 3x squared like that. My apologies. Here, 3 is greater than 1, so we have a horizontal compression by the reciprocal of 3, which is 1/3. Again, think about the points of your parent function here. If you need to. You're changing the x values. 0, 0 stays the same. 1, 1, I'm multiplying 1 by 1/3. So that point's going to be at 1/3. The y stays the same. So it's going to be kind of tight in here. That's all right. Estimate that. 2/4. Multiply the 2 by 1/3. You get 2/3, 4. So again, still inside the 1 there. 2/3, 4. Right around there. And then 3 times 1/3 is 1, 9. So go up to 9 here. And we have a really skinny graph. But that graph was horizontally compressed by 1/3. Okay, and since I goofed up the typing here, this equation would be parentheses 2x squared, and this guy would be 1/3 x squared. All right, there's example 3.